This problem is a twist on a classic optimization problem. The classic optimization problem is usually we're given some sort of fencing and we want to find the maximum yard or the maximum area we can make. This time we're given a fixed area and we want to minimize the cost, knowing that these sides cost $1 each, this side, and this side. But this last side is made out of heavy-duty material, which costs $9. So we want to make a yard that encloses 500 square feet or 500 yards, square yards, or whatever, knowing that these are our costs. So here's what we're going to do. We're going to say, what's our constraint? We're going to go ahead and label the sides of our rectangle. Let's do our new rectangle here. We've got x and y. The area of this rectangle is x times y, and it needs to equal 500. This is our constraint. Our constraint is no matter what rectangle we make, we want the rectangle to have an area of 500. The primary function we're trying to minimize is the cost function, but it doesn't seem obvious how to make a cost function just yet. Let's go with what we know though and say we know the perimeter will be an x and an x, so 2x, and y plus y. So that'd be 2x plus 2y. Now the problem with this is that this is a perimeter function, not a cost function. So how do I turn this perimeter function into a cost function? Well, bear in mind that these sides, namely this x, and this 1y, each cost $1, while this side of length y costs $9. With that in mind, I'm going to do something a little peculiar. I'm going to split this 2x plus 2y into x plus y plus y. Now I know that seems kind of stupid because I could combine the x's and the x's and the y's and the y's. But I don't want to do that because I want to assign a cost to each of the different sides. So each side labeled x costs $1. And one of these sides labeled y costs $1, but it is this last y side that costs $9. And so now I've transformed my perimeter function into a cost function. I have x plus x is 2x and y plus 9y is 10y. Okay, this is the primary. This is the thing that I'm trying to minimize. Unfortunately, my primary has two variables. That's why I solve for one of the variables in my constraint. I'm going to go ahead and solve for x in this constraint. That means I'm going to divide both sides by y. So I'm going to get x equals 500 divided by y. Now that I've done that, I can take x equals 500 divided by y and plug it into my primary. That's going to give me c equals 500 over y times 2 would be 1000 divided by y plus 10y. Now my primary is all in terms of one variable. This is where I use calculus to take the derivative. So c prime equals negative 100, or 1000 rather, over y squared plus 10. I set this equal to 0 because I'm trying to find a minimum or a maximum. In this case, it's a minimum. And I'm going to solve for y from here. This is going to give me, I think, y equals 10. So if I'm going to subtract the 10, the flip both sides, multiply over, stuff like that, and I'm going to get y equals 10. Now that I have y equals 10, I'm going to take that, plug that back into my constraint, namely that x is equal to 500 divided by y. So x would equal 500 over 10, or x equals 50. Okay. Now that I have x equals 50 and y is 10, I can finally get the cost because I now know what the sides of this rectangle are. If x equals 50, I'm going to plug that in there to get 2 times 50 plus 10 times 10. 2 times 50 is 100, 10 times 10 is 100, so I have 100 plus 100 is $200, and that is my answer.